Hi, welcome back for what's going to be the final lesson in our patterns and functional notation unit. And the concept we're covering in the next couple days is identifying slope and intercepts of lines. Let's go. Here are the North Carolina Extended Math Standards that we have covered in this unit. And by the end of this lesson, you should be able to say, I can compare two lines on a graph. So what are you working for today? First, we're going to do our lesson and activities, then we'll take a break. We're going to use a lot of common words today. A lot of stuff in this lesson, but you know what? It's all good. First word is line. Then we have the word graph again. We'll talk about increasing, which means things are going up and they're getting bigger. We'll also use the term decrease, which means things are going down or getting smaller. So let's hear what Tim and Moby have to say about slope and intercept.
Well, this seems like a good time for a letter. Dear Tim and Moby, how do I find a line's slope and intercept? From Dana. Let's start with slope. The slope of a line is another word for its steepness. This ramp, for example, is really steep. In math, slope is just a measure of how something changes vertically, or up and down, compared to how much it changes horizontally, or left and right. Well, to find a line's slope, you've got to look at two or more of its points. The line of this ramp can be thought of as a series of points that are connected. Right, the best way to visualize this is with a coordinate plane, a two-dimensional representation of space. For details on that, check our coordinate plane movie. Every point on a coordinate plane has a numbered location, kind of like coordinates on a map. A point's location along the y-axis is its y-coordinate, and its location along the x-axis is its x-coordinate. To find the slope of a line, you need to find out how much its coordinates change as the line goes along. Alright, let's take a look at 2 points along this here skate ramp. One point has the x-coordinate 5 and the y-coordinate 6, while the other has an x-coordinate of 0 and a y-coordinate of 1. To figure out the slope, we want to find out how the positions change exactly. The slope, or m, is equal to the amount of change in the y-coordinates divided by the amount of change in the x-coordinates. Right. Some people call that rise over run. It helps you remember that it's a vertical change over a horizontal change. Let's try it for the ramp. Our two y values are 6 and 1, and our two x values are 5 and 0. So the slope for this ramp is equal to the change in y, that's 6 minus 1, divided by the change in x, or 5 minus 0. The slope is 5 over 5, or 1. In other words, for every 1 meter this ramp goes up or down, it goes across 1 meter. You can find the slope of any straight line the same way as long as you know the coordinates of any 2 points. Maybe you should go first. Oh, almost forgot the intercepts. An intercept is a point where a line hits or intercepts the x or y axis. For our ramp line, the x-intercept is minus 1, 0, and the y-intercept is 0, 1. Well, the y value of the x-intercept is always 0, and the x value of the y-intercept is always 0. What? That's just what happens. Using the slope and one intercept, we can write an equation for that line in what's called slope-intercept form. Slope-intercept form is expressed as y equals mx plus b, where m is the slope and b is the y-intercept. So for our line, that's y equals 1 times x plus 1. You can use this formula for all sorts of things, like finding more points on the line and even graphing it. Watch our Graphing Linear Equations movie for more on that. Yes. Yes, we did what we came here to do. To the stairs.
All right, so you're probably saying to yourself, well, who really cares about the slope of a line and all that? But we use slope all the time. We don't always calculate it, but we look at the slope all the time. And a great example of this is a roller coaster. The first thing people look at when deciding if they want to go on a roller coaster. They look at how steep that line is. Does it go straight up and down, which some of them do now, or is it more of like a kiddie coaster that's a little bit more flat and not very steep at all? So, just to get our connections going, we're going to take a ride on an old wooden roller coaster. And while we're going up and down the hills, think about how steep or not very steep they are compared to the others. Get ready for your ride on the Timberwolf. Wooden roller coasters are really bumpy and loud, so be prepared. Well, I thought that was fun. I'm not a huge fan of roller coasters, but it brings back good memories being on some of those when I was younger. And if you'll notice, some of the hills were really, really tall, and some of them were a little bit more flat. And that's what makes a roller coaster fun, is that the hills have different slopes. It wouldn't be fun if they were all super scary and then you just went up and down hills the entire time. So they design them. So usually the biggest hill is at the very beginning, which gets you going. And then there's different hills of different sizes along the way. It makes it much more fun and interesting. So remember when we were learning this before, that a line shows all the answers for an equation. Each point on the line can tell us information. The places where the line crosses the x and y intercepts, or crosses the x and y axis, are called the intercepts. And we have a graph here. And it looks like my tool is not wanting to switch back out of the pen tool, so just a second here. There we go. We have an x-intercept on this line. That's where it crosses the x-axis, or the x line. Here is the x down here, where does it cross? It crosses at the number 7 there. That makes it a little bit easier to see. That's where my equations line crosses the x-axis. Now for the y-intercept, we're going to come over and look, and let's again move this circle a little smidge. See where the line, the equations line is crossing the y-axis or the y line? Well, that's at number 10. So we say the x-intercept is 7 and the y-intercept is 10. The slope of a line describes a line like it is a roller coaster. The smaller the slope, or the slope is smaller like a kid's coaster. See this one? That's a really small slope. And it's a lot like the kiddie coasters, which are really fun, but they're not very tall. So this line is also not very tall. It's considered a small slope. Now, look at this hill right here. That goes pretty much straight down. Not my favorite kind of roller coaster, but I'll do it. This is what we would consider a very big slope. And look at this line over here. Do you see how it's much taller than the other line that we had before? This is a bigger slope. Now, we can also talk about the slope in two other ways. The slope of this line right here that we're looking at is positive because it is moving up or increasing. So, do you see how the line, we always talk about where it's going from over on the y-axis. We look and it's heading up. So we would say that's a positive slope. This picture of a roller coaster is also going up the hill. So it's increasing, which would mean it's a positive slope. Now, the slope of this new line is negative because it's moving down or decreasing. Now look, again, I'm starting where the y line is, and I see that my line is moving downhill. That's considered a negative slope because the numbers because it's going down. And we see here's someone going down the hill. The slope of this roller coaster hill would be negative. The slope is calculated by counting how many spaces up and how many spaces to the right. So we put any 2 points on a line. We put a point here, and there's a new point here. So what you do is you count first, how many spots did you go up? And look, I went 1, 2, 3 spots up. So I'd write that on the top, up 3. Now I need to count how many spaces to the right. 1, 2. So my slope is 3 over 2. That's it. Just counting spaces. The slope describes a line on a graph. So I'm recommending for a brain break that you may want to do another roller coaster. This one we're not going to ride, we're just going to watch as it goes. But this one goes pretty much straight up and down. Yeah, it's a lot. Okay, so let's look at the Kingda Ka Off Ride at Six Flags Great America, or Great Six Flags Great Adventure. All right. And this metal coaster is a much smoother ride than that previous wooden coaster. Does a little twist at the top and on the way back down too. Here it goes again. Little closer view. There's the twist. Now it's up to a bigger twist.
Please unbuckle your safety belt.
Welcome back, riders. How was your ride?
All guests wait.
Please unbuckle your seatbelts and you guys will exit out the left side.
I hope you had fun watching those people on that coaster, and I'm glad it's them and not me. That's a little too straight up and down for my personal liking. Now, remember, the slope describes a line on a graph. Now, let's do some questions. And remember, before answering a question, number one, listen to the question. Number two, listen to all the answer options. Number three, think about it. And number four, answer the question by choosing one option. All right, and remember, intercepts are spots where the line crosses the X and Y lines, or axes. Place the dots on the correct intercepts. So let's see, the x-intercept is at number, well, let's go down to the, oh, you know what, I need to move my little thing out of the way first. So I can see that the x line is this one right down here. So let's see where the equations line goes and crosses it. Uh-oh, it looks like my little dot is not see-through. So I'm going to move it over top and I'll have to fix that. It looks like we are at the number 8. So it crosses at the number 8. Now let's see if the other one works a little bit better. Now, the y-intercept is at number, let's see, here's my blue line. Let's see, where does it cross? There it is. That's number 9. So our y-intercept is at the number 9. Great job. Thank you for helping. All right, now we're going to sort the lines as positive or negative slopes. And remember, a positive slope is going up, up. And a negative slope is going down. It's going down the hill. This is probably a little bit easier for me to do. There we go. It's going downhill. So think about like if you're sledding or doing anything else, or if you're out for a walk. Sometimes we go up the hill and sometimes we go down the hill. So positive is up the hill, negative is down the hill. This one looks like it's going up the hill. Which other one do you think is going up the hill? That looks like it's going down. I'll put that into the negative. This one looks like it's going up the hill. So these two are positive. They are going up. Now I found one negative that's going down. This other one also looks like it's going down. So that would also be a negative slope. Thank you for helping me with that one. Now, I've got a question for you. We're going to compare two hills, all right? I see that the first hill right here, and I see a second hill right here. Which line has the bigger slope? Remember, we're looking for big, and I'm going to give you a hint. Which hill would be scarier if you were on the roller coaster? Would number one be the scarier or bigger slope? Or would it be number two? What do you think? Which one has the bigger slope? Which one's taller? Number one or number two? If you said number two, you are correct. This hill right here is definitely taller and steeper, which means it has a bigger slope. Great job. So now what we need to do is count our slope. So we need to calculate the slope, we need to see how many spaces up and write that number over how many spaces we go to the right. Well, let's see. We have our points here. I have a point here and a point here. So how many spaces did we go up? Ready? Count with me. We went 1, 2, 3, 4, 5 spaces up. So we went 5 up. And now let's see how far we went over. Ready? From here, from this spot, we go 1, 2, 3 spots to the right to get to our dot. So, which one is our slope? Is it 5 over 3? Or is it 2 over 9? Which one is our slope? If you said 5 over 3, you are correct. Great job. Remember, the slope describes a line on a graph. The common words we used today were line, graph, right. Then different words that all mean to get bigger are increase, up, and bigger. In math, they all mean similar things. Now here's 3 more words that mean about the same thing in math. Decrease. It means our numbers are going down and our numbers are getting smaller. So let's go. It's time to do your activity with your teacher or an adult at home. The link is on Canvas and down below. Enjoy your next trip to the amusement park.